Welcome back. Now we'll be talking about application allowlisting. My name is Roman Števaniak. I am a senior security consultant from the Copenhagen office. And today we'll be talking about what falls between the cracks of application allow listing. First, we will talk about what the tevan is and what are some challenges in its implementation. Then we'll talk about some built-in Windows mechanisms for enforcing that. Then we'll talk about some common misconfigurations that we see in different types of engagements from a regular internal penetration testing to red teaming. And then we'll talk about more advanced techniques that could be used to bypass them. So first, workstation allow listing would mostly be a mechanism that is trying to enforce what should and should not be run on a typical on a computer, right? So in this use case, for a classic workstation computer, we would expect it to run an Office suite, email communication application, chat application, maybe some web browsers, and third-party specialized tools. For a shared workstation, for example, a jump host or a shared station with a licensed software where everybody has to log in, we would expect only to run that software, maybe some administration tools. And then, for example, for a server, we would expect application server to run only applications, database servers to be running databases. They would usually require some third-party code, and they also have to be allowed to update for obvious reasons. So goals in general for application allow listing would be to enforce that only this and only what is supposed to be running is running on the server. Of course, one of the main goals is to not hinder the application or the user or the worker in any kind of way, because if that happens, then the whole point of the workstation or the server kind of loses its purpose. We do this because if an attacker would get on that machine, on that server, on that workstation, this could be used to slow them down, in some cases even stop them, and make them use louder and more complicated techniques that could maybe be picked up more easily by detection and monitoring. So application listing is hard. Doing it properly is hard. To demonstrate this, we can look at this simplified model of different scales of application listing. On this side, there are very strict limitations. Nothing can be run. Attackers cannot run anything if they get there, but neither can application. Right? On this side, there would be absolutely no limitations. So if an attacker got there, they could just run anything from any folder without any concern, and the application could also be running seamlessly, because it could run its updates, drop any exes, and run anything. So this is what attackers could see, right? They would be more efficient with no limitations, and as limitations become stricter, they would also be limited more. So now let's imagine we have to secure an application, right? We have a very simple one, so it can live here, right? It can deal with strict limitations because it just needs to run one executable, does not need anything else. In this case, that would be pretty nice because we can just set the policy to be around here, so it has some space if it does something more suspicious, something strange, but also attackers are hampered significantly. However, let's say that this simple application is updated and now it has extra functionality. Let's say that now it also needs to be some built-in Windows tools. That's fine. Now let's say it needs Python, so it also has to include Python interpreter. Well, that gets us dangerously close. Now let's say it includes a third-party software which for some reason likes to drop exes into a temporary folders and execute them. Well, in that case, it is pretty out there, and there is no line where we can draw it, which could stop the attacker from doing the same and succeeding, and the application still running, right? So as the application has to run, it has to be somewhere in here. If we want to stop attackers, it would need to be there. So that's one significant challenge that just echoes through all of this. But there are quite a few more, right? The configurations are unique for each server, each workload, so they have to be also made for each one individually. Also, these are too complex for like straightforward solutions that would just point and shoot and work. Often also we're trying to secure third-party applications, so we do not have full control over them. We can't go to the developers and tell them like, oh, do not use this functionality. This will make it way too hard to secure. And also it requires a lot of maintenance because one day they might update something, folders will change, folder names will change, file hashes will change, and the administrators will also have to change everything to suit it. The last significant challenge would be that the classical asymmetry of attacker versus defender. That attacker wins if they find one flaw, defender wins if they find all of them. So now we can talk about some built-in Windows mechanisms that can be used for enforcing the application allowlisting. So first, there with Windows XP and Server 2003, there were software restriction policies. They were deprecated with Windows 10 and Windows Server 2019. Then came GAppLocker with Windows 7 and Windows Server 2008. And then there is WDAC or Windows Defender application control, which also bring extra functionality. So broadly speaking, all of these mechanisms are trying to control what software is supposed to be running based on the rules, like all of the executables in this folder and its subfolders can be run, or all of the DLL, the libraries signed by this publisher can be loaded, or this very specific installer with this specific file hash can be run, which is very handy for 7-zip. These are the kinds of rules that these are making. So if we go around them one by one, the software restriction policies was the first one to come around. However, it had a few drawbacks. It could be pretty challenging to set up, and also from the get-go, it was not really built to be allow list by default, which is also reflected in Microsoft official documentation, where they caution users against doing that, saying like, if you are trying to do that, just be sure that you know what you're doing. Then there came GAppLocker, which was denied by default, allowed by exception, which was an upgrade on that. So it also had brought a lot of convenience features for setting it up. For example, it has an audit port where it can be just set up to log and not enforce the rules. So you can, before you fully enforce it and block people from doing their job, you can at least see what are they running and make new rules based on that. And it can also apply to individuals and groups. Then there is WDAC. It also brings extra new rule possibilities. So for example, now you can also make rules like if this application is running this, it is allowed, otherwise it's not. Or or it can also check if an executable is being run from a folder which is writable by user, which is very handy. For example, if a certain folder would become writable from overnight by users, then administrator would not be able to run a tool which could be written by a user potentially. It can also control drivers, which is handy, and policies can also be signed. So that means that even if an attacker would gain the local administrator privileges, they could not just override the policy without also getting access to the signing mechanism. At the moment, the WDAC and GAppLocker are still both in use and not being deprecated. The official Microsoft guidance is that one should try to use WDAC if they can, and they can also be both used at the same time, with WDAC being serving as a base and GAppLocker being used to fine-tune the rules. Aside from these three main mechanisms, there are also other smaller things that can be done to make attackers' life harder. However, these should not be considered more than additional hardening, because it can happen that that one would read a line like this: run only specified Windows applications, and think that this is an actual application allow listing, and it will stop the attackers from running it at all times. We will mention this later. So yeah. Also worth mentioning is PowerShell constrained language. It was introduced with PowerShell 3. It's also automatically deployed with GAppLocker and WDAC. It is allows some dangerous functions which could allow PowerShell to be just running absolutely anything. And important thing is that if this is in place, PowerShell 2.0 has to be disabled. Otherwise, because PowerShell 2.0 does not know anything about constrained language, so if it is in there, attacker can just run that and run as if it didn't exist. The constrained language was not set up at all. So now we'll talk about some common misconfigurations that we see in a whole scale of engagements, from internal pen tests to red teams. In broad speaking terms, the biggest one is still using block listing instead of allow listing. The usual argument is that it is just impossible to think about everything in advance, and you're bound to forget something that an attacker might use later. So in a very recent engagement, there was a Citrix virtual application, and after breaking out of that, we got access to the file explorer. We were disallowed from using PowerShell or CMD and all of that. However, what we were allowed to do was copying PowerShell executables to a different folder, renaming them something else, and then they worked just fine. Another case was by a colleague of mine in an engagement. They were in an organization. They had an access to a laptop. They were trying to see what they can do. They were just going through the techniques one by one. Oh, this will be blocked, this will be blocked, this will be blocked. And then they realized that only 64-bit utilities were blocked. Their 32 Windows equivalents were allowed. So yeah, they just used those. Another point is insufficient granularity. So the first point, C Windows and C program files, these are allowed with default AppLocker deployment. However, these folders also contain plenty of user-writable subfolders, for example, notorious C Windows tasks. So if there is no scrutiny for these rules, it would be very easy for an attacker to just place an executable there and use it. Another case I heard from a colleague was that all of the computers in the environment had the same policy. So they had a laptop, they had a workstation, and they were listing through the applied rules, and they saw a lot of subfolders in C, which did not exist on their laptop, and they were clearly meant for a server. So yeah, they just made those folders, and everything worked again. So it is important to have that. Also, another case would be using inefficient measures. So in this case, a virtual application again, we broke out of that kiosk. We got access to a file explorer. We tried to run command line cmd.exe. Command line has been disabled by your administrator. Okay. We tried PowerShell. Well, that operation has been cancelled due to restrictions on the computer. Okay. Then we tried running PowerShell through the command line, and that worked for some reason. So when it happened for the first time, I was kind of mystified. When it happened second or third time in a very distinct environments with different clients, I had to dig deep to find out what it actually was that would happen. So the problem for this has to happen in two places. There are two misconfigurations, right? The first one is one of the miscellaneous settings that I mentioned is prevent access to command prompt, right? It has a subsetting saying disable command prompt from script execution as well. By default, it is on no. Also, when you read the description, it also says that if you set it to yes, it can hamper some logon scripts and stuff like that. So it is understandable that administrators would set it to no. So this would allow cmd-c to run anything. The second problem was that PowerShell was disallowed by this security measure, which was the one that I pointed out. run only specified Windows applications. Thing is, it sounds pretty good when you read the setting like this. However, in the description it states that this is only to block stuff from being executed from the file explorer or the desktop or stuff like that. So while we couldn't run PowerShell from anything directly, once it was run through CMD, it would just work. All of this listing would not be applied. So to avoid these common pitfalls, you should always use allow listing over block listing. Be as granular as possible. Use separate policies for separate use cases. Scrutinize the default rules, and rely on the dependable security measures. So WDAC and AppLocker, and just add the other measures just for hardening. So now for the more advanced techniques, which even a properly set up application allow listing might have some problems with. So we'll talk about living off the land. This was introduced as a concept, or the first talk on it was on DerbyCon 3.0 in 2013. The idea is that as an attacker, it might be advantageous to blend in with the tools which are already present in the environment, either because they are expected to run on the system, so laying a bit lower with the monitoring and detection, they would be signed usually, or they would be allow listed where they should be allow listed. The thing is that these usually have a lot of extra functionality which people who set up these things did not know about, and we could use. For example, if one of the trusted applications would be Microsoft Office, one of the classic things would be to open Microsoft Office, go to macro editing, and use VBA to further the attacks. Or if a third party had a Python interpreter, it is being allowed to run on the system. So just using that, and then we have all of the attacker would have all of the Python tools that they would want. Or 7-zip is a good example, because 7-zip historically has had a few problems with being signed. So any rules that would involve 7-zip would either have to rely on the file on the file location or the file hashes, which would be very difficult to set up from the administrators. So there might be some surface to explore there. Then there is this project, Living Off the Land Binaries and Scripts, started by Odvar Mo. It is a repository of Microsoft signed executables, which also have a lot of extra functionality, which people don't usually know about. They could be used to download or execute stuff and bypass allow listing. Another point worth mentioning is that bringing your own binary is also a thing. So if application allow listing would, for example, have a rule that, we only allow stuff signed by Microsoft, and even if that binary is not on the system, that does not mean that an attacker cannot bring in a signed library. Classic example is using sysinternals, which is a suite of Microsoft-made legitimate tools that also administrators use from time to time. And AD Explorer is a good example, because it is a tool to look through Active Directory, and it has been routinely used in red teaming exercises to look through the network and save it, so it can be analyzed offline. Last I heard that there are some detections nowadays, but it's been an evergreen for a long time. Another widely used technique for initial injection into the environment, gaining a foothold, would be application prone for DLL hijacking or subdomain hijacking. So use case there is that the victim, the phishing victim, would be given a pack including an executable, which is a valid signed executable, non-modified in any way, and a malicious DLL, which we know the executable would load. In this case, in the monitoring in many different toolsets, it would show up as legitimate. However, it would be just running the malicious code. Another technique would be using a malicious plugin. So let's say that there are several common applications that would be allowed in the organization, like text editors like Obsidian or development tools, and these applications would have a functionality for extending. Usually, these plugins or these extensions give a lot of power to the hands of the developer developing this plugin or extension. And as these applications are allowed in the environment, they would be running. If we put in the malicious plugin running our code, it would act like the application. It would show up as the application, and it would be great because it is less detectable, and it also is great if it uses the internet. If the application is known to use the internet, we would also blend in that regard. Just to illustrate this, this is a official Obsidian website talking about plugin capabilities, saying that they cannot reliably restrict it, and if you are working with sensitive data, you should perform an independent security audit. Last technique worth mentioning is ASR backdooring. So there are plenty of Electron applications usually deployed in the environment, old teams, not the new one, Slack, Signal, the Obsidian or Discord. These usually use ASR archives, which are usually not checked for integrity, not signed. As far as I know, there have been only some experimental features with integrity checking. These contain application code, so they can be overwritten, and they would basically be running as the application itself. The malicious code will be running in the application itself. There is also a public tool doing that, and we also have our own internal one. So how do we face this? It is important to remember that application allowlisting should be just one line of defense between the others. So, for example, if an attacker did a malicious plugin, and now Obsidian is trying to look through the domain and execute code on other computers, that should be caught by detection and response and monitoring, right? If that is happening and plugin is also trying to do something the user shouldn't be able to, that should be clashing against least privilege principle. And also there should be also network filtering, so just the attacker, even if they got past this, could not get further. So the takeaways from this would be that application allowlisting is tricky to make perfect. It is a defense in-depth security measure. It is just another layer, and needs to be in tune with monitoring. So if the attacker is clashing against that, monitoring should know. However, it is very much worth doing. Thank you very much. Are there any questions?
Have you ever seen PowerShell and command prompt?
Oh, I got me.
Thanks. Have you ever seen PowerShell and command prompt successfully blocked, yet still allow scripts to be run?
I don't think I saw it per se, but do you mean like CMD -C PowerShell would not work and command prompt would?
So
scripts would.
Admins would love a bit of logon scripts and what have you.
Yeah.
So to enable those, but then if an attacker got a foothold, to then prevent execution into these.
Yeah. Like PowerShell. So in this case, it worked because also PowerShell was not disallowed by GAppLocker or anything else. It could actually be stopped like this. Like that control, like CMD would be disallowed interactively, but prompts would the scripts would still work. That is a valid setting, right? As long as the PowerShell is also disallowed with other mechanisms, right? And also it is worth thinking if there could be separated, right? Like some users may be allowed to run scripts. Some users that we don't want on a command line should not be able to run scripts, right? Because also like if they are run under that user, scripts are run under that user, well, they can just probably rewrite those scripts, and yeah, we're back at square one. They do not have it interactively, but yeah.
Thanks.
All right.
So, any other questions? Thank you.